affinity is the amount of energy released when an electron is accepted by an atom, although it's generally measured in kilojoules per mole of electrons accepted. So take a look at fluorine here. Now, it is not very stable at the moment, and there's also a fairly unstable electron out in the vacuum as well. But these can both be stabilized by the electron being accepted into the fluorine and joining principal energy level 2. This decrease in energy, this stabilization as fluorine accepts the electron to become fluoride, is due to the negatively charged electron getting closer and closer to the positively charged nucleus. There is a stabilization and a lowering of energy when oppositely charged particles come close together. Now, there's also a stabilization in this case because the electron is filling principal energy level 2 on the fluorine, creating a noble gas configuration, filling the valence shell. Now, we can see that as that electron is accepted by the fluorine to become fluoride, energy should be released. As there was a stabilization, a lowering of energy, energy must have been released. If energy cannot be created or destroyed, so if there's a lowering of energy of the system, the energy must be going somewhere. So we have a negative enthalpy of this process, yet the activation energy is defined as the amount of energy released when this occurs. And so we take this delta H and we make it positive. That is the electron affinity. Now, oxygen also can accept an electron, and that also will be somewhat stabilizing. Not so much because it creates a noble gas configuration, which it doesn't, but it's still stabilizing to have an electron which was out in a vacuum, not near any positive charge, and now make it near the nucleus of the oxygen atom. That is stabilizing, though not as much as for fluorine. And therefore, there is a smaller electron affinity for oxygen. Yet, neon, if it accepts an electron, yes, it might be somewhat stabilizing for the electron to come near the nucleus, but there's a lot of destabilization that occurs because of the negation of the noble gas configuration. Neon had a noble gas configuration. It had a filled valence shell, but accepting another electron, it started filling the next valence shell and therefore was not as stable. So this is an endothermic process that has a positive delta H, and so therefore the electron affinity is negative. We can track the electron affinities of a variety of different elements. We can see that the halogens, the group 7A elements, have the highest electron affinities. They are very much stabilized to accept an electron because that will give them noble gas configurations. Group 6A elements and others are somewhat moderately benefited and stabilized by accepting an electron, but not as much as for the halogens. And then the noble gases, they all have electron affinities that are less than 0. They are destabilized when accepting electrons. You can write the highest electron affinity is for the halogens because they're most stabilized when gaining electrons, because that gives them noble gas configuration. And noble gases are actually destabilized and have negative electron affinities because that gets rid of their noble gas configuration. Thanks for watching, guys.